Problem number 80. Find eigenvalue and eigenvectors of a given matrix A, which is a 3 cross 3 matrix. Our matrix is 2 0 1, 0 2 1 and 0 0 3. We have 4 options. Each option has eigenvalues and respective eigenvectors. Now in this problem we will use short trick for calculation of eigenvectors, which is valid only for 3 cross 3 matrix. We have already done for 2 cross 2 matrix. Now we will do for 3 cross 3. From definition of eigenvectors, we will write our characteristics equation. Characteristics equation is a minus lambda I is equal to 0. Now our matrix will become 2 minus lambda, 0 1 and 0, 2 minus lambda and 1 and 0 0 and 3 minus lambda, which will be equal to 0. We will expand along column 3. We will get 2 minus lambda whole square and 3 minus lambda is equal to 0. Now we can write lambda is equal to 2, 2 and 3. So our eigenvalues are 2, 2 and 3. Now corresponding to eigenvalue 2, we are going to find eigenvectors. So this is our lambda. We will consider a minus 2i into x is equal to 0, and our matrix will become 0 0 1 0 0 and 1 0 0 and 1, and our variables are x1 x2 x3, which will be equal to 0 0 and 0. Now as this matrix is not in echelon form, we will try to reduce in echelon form. We will use operation R2 minus R1 and R3 minus R1. Now our matrix will become 0 0 1 0 0 0 0 and 0. Our variables are x1 x2 and x3, which is equal to 0 0 0, and finally rank of matrix is 1. We have total number of variables as 3, and free variables will be 3 minus 1, which is 2. Now 2 variable means 2 variables mean 2 independent vectors. So our equation will be, we have only one equation, as we have only one non-zero row. and we have two 0 row, 0 row. Now our equation will be, we have only one equation. The equation becomes x3 is equal to 0. So we will assume our next variables like x1, which is x1 is equal to k1 and x2 is equal to k2. We can take anything, k1 and k2. In place of k1 we can take alpha, in place of and k2 as gamma. We can take any value, but in this problem we will take k1 and k2. Our variables are x1, x2, x3, and which is equal to x1 is equal to k1, x2 is equal to k2, and x3 is 0, and x3 is 0. Now we will separate variables, which will be equal to k1 1 0 0 and k2 0 1 0. So finally our eigenvectors are 1 0 0 and 0 1 0. So corresponding to lambda is equal to 2, we got two independent eigenvectors. Now corresponding to lambda is equal to 3, we will find eigenvector. We will try to find with short trick. We will use short trick to find eigenvector. Now consider a minus lambda I into x is equal to 0. Now minus 1 0 0 0 minus 1 0 1 1 and 0. This will be a minus lambda I, which will be multiplied by x1, x2 and x3, and which is equal to 0 0 and 0. Now using trick for 3 cross 3 to get eigenvector. Now our trick will be select two non-zero row. Select two non-zero row from a minus lambda I, and then apply AD minus AC. We will use two of our non-zero row. This is our first non-zero and this is our second non-zero row, and this is 0 row. 0 row. This is 0 row. Now we will use, this will be middle, this will be last, this will be first, and this will be again middle. We will write middle element, which is 0 and minus 1. Here we will write 0 and minus 1. Last is 1 1 1 1, and first is -1 0, -1 0, and middle is 0 -1, 0 -1. Now we will apply AD minus BC. Now we apply AD minus BC. Which will be x1 x1 by 0 plus 1 and x2 by 1 into 0 minus plus 1, which is 1, and x3 -1 into -1, 1 into 0 will be 1. Now we know x1 and x2 and x3 values. Now we know the values x1 as 1 and x2 as 1 and x3 as 1. So this is our short trick for 3 cross 3, which is only valid for 3 cross 3. Therefore eigen value is 1 1 and 1. This trick is applicable only for 3 cross 3 and distinct eigenvalues. So eigenvalues should be distinct, not for repeated eigenvalues. Now if we have 2 repeated eigenvalues and 1 distinct eigenvalues, we cannot say total number of eigenvalue is always 3, as if we have a repeated eigenvalues and number of independent vectors are dependent on free variables. That's why if all eigenvalues are distinct, we can give the conclusion, but for repeated eigenvalues we cannot give conclusion. And even if all eigenvalues are distinct, we can use this trick for 3 cross 3. Correct option is option C.